Hey, good day, and if you came across this video, I think you're going to be in for some interesting stuff here. This represents a storm chase of mine after I left Kansas City teaching a course on damage surveying, and I ran into this storm here, not entirely by accident, but somewhat on purpose because I saw a pretty good risk here. And there's some really cool stuff here. I took a couple different time lapses, and what I'm going to do is merge the time lapses visually with radar and satellite data and lightning data and kind of go do a walkthrough of data fusion to show you a few pointers as to what kind of features show up in which kind of setting, either photography, visual, in person, by satellite, and by radar. So we're going to take a look at the loops, the individual time lapses first. Then I'm going to go through a silent display combined with all the data. And then after that, I'm going to go through a narrated talk about looking at all this. That's going to occur probably about after 3 minutes worth of looking at it all in silence. And for the next 20 minutes after that, I'll talk about various aspects. First, the onset of the storm and turning and having it turn into severe storm into a supercell, and then after that, the onset of low-level mesocyclogenesis. So hope you enjoy the show, and you can zoom and skip around as you see fit, because this is YouTube, and that's what people do. All right. Okay, and thanks for taking a look at my video and the time lapses. They were in silence before, but now we're going to go ahead and I will go and narrate what I'm seeing in all of these panels here for the two phases of this storm here that first started up northwest of Manhattan, Kansas. Here it is. We're located again east, southeast of the storm itself, and as of about 2318 UTC, it's mostly in a multi-cell phase. You can see individual cores here at the 6.4 degree altitude from the Topeka radar. And at this altitude, the temperature is roughly minus 20 degrees, and you can see this area is occupied by multiple individual reflectivity cores. At this altitude, at minus 20 degrees Celsius, usually the updraft and the high reflectivities are well correlated. So let's just assume that's the case here. And over here, you can see some areas of enhanced inbound. That's on the south flank of some of these more intense cores, but really nothing very coherent, and certainly not at the surface here, where we have multiple small and weak downdrafts impacting close to the ground. At the distance that we're from the radar here, the elevation of the half degree is about 2 to 3,000 feet above ground. Here also you can see one major core. This core here is associated with that elevated core there. And then these new upcoming cores are really just kind of isolated, and the precipitation hasn't really reached the ground here. If you look at it from the surface, okay, here's my spot, and I'm looking to the west-northwest, and here you can see from the surface, it just looks like one large anvil region here, and what appears to be is one updraft base down here, way in the distance. But you might be able to see back here behind these low clouds multiple updraft cores. So you see updrafts here and here, and this is along the flanking line to the southwest. If we take a look at the satellite at this time, you can see the arrow pointing towards a small updraft feature here, just starting to produce an anvil, and then the major anvil here with the more mature core, which you can see certainly in the visible imagery here from the ground. It is my location, which is on the southeast flank of Tuttle Creek Reservoir. Lightning is occurring up in the anvil. You can see this from the Global Lightning Mapper Flash Extent Density product. So yes, we do have an active thunderstorm. Now I start moving forward a little bit, and I got basically one frame every 2 seconds going here, and immediately you can see that updraft just hinting back here, the silver lining around the dark cloud behind this low cloud. Right there is that updraft surging up, and you can see it joining with the pre-existing anvil here on the 1 minute GOES-16 satellite. By the way, this is the sandwich product with the IR pasted on top of the channel 3 or the 0.64, the channel 2.64 micron imagery, which is the red channel. That's the channel that most people look at with visible imagery. So go forth in time, and you can see now the onset and explosive production of this core, and that's the core you see here, the anvil starting to spread up and out, and from visible imagery, the anvil you can see growing with time. No sustained mesocyclone except with this original core here. So let's go forth a little bit more, and you can see the anvil expanding out dramatically, flaring off. Still well-formed updraft base, which is kind of representing the composite of all these updrafts here. And as we go forth, you're going to start to see the onset of the mesocyclone in the 6.4 degree reflectivity as I go forth. Okay, right here now you can see the new surge and the anvil pushing out from that surge. Better identification of the updraft base with a lowered base here, representing cooler air emanating from the reflectivity region, reaching the ground. And the anvil is merged with the new anvil, or the new anvil is now merged with the old anvil. As we go forth, now look at this here, right here at 2329, you can see a substantial increase in inbound on the right flank of the new core here, or the new updraft, represented by the 6.4 degree, and now the reflectivity is reaching the ground. Can't see that reflectivity here. All we see is just one composite core. But the reflectivity is probably back in this region here and then reaching the ground here. You can see just light reflectivity at the lowest elevation angle, so it's really not visible to the naked eye here as we see from the Tuttle Creek Reservoir location. And we go forth in time, and you can see the anvil. Now you can see a surge or a drop in precip right here. You see the increase in the core of that new cell right in this area here. And you can sure see it in the actual time lapse. Suddenly the core drops in this area. This whole area becomes opaque, and boom, it just kind of consumes and conceals this right extent of the wall cloud. At this point, we start seeing this really strong inbound area at mid altitudes. It's the onset of the mesocyclone. No B word yet, but just onset of core. Now down at low levels, you can see outflow suddenly surging in here, and we start to see a gust front, rear flank gust front forming. And let's move it forward a little bit more. And oh, by the way, you can see up here in the GOES-16 storm top, real big overshoot formings with a new lightning core at this time. This is 2335Z, and we move forward a little bit more. And now we start to see at this point at 2335 the onset of a well-developed BWER and the reflectivity core really consolidating down here. Low-level convergence with a little bit of shear on the north side at the low levels with a strong mid-level mesocyclone at roughly 18 to 20,000 feet. Now you can see we lost the IR, but you can see this massive overshoot on the satellite. And with lightning, kind of hard to see. I'm amazed actually that I don't see more lightning activity in the GLM. I just see very low values of flash extend density. I would have expected higher than that. But you can see in the visible imagery, well, now a well-defined anvil edge, solid right flank to the updraft, and the updraft base here over time. Now we're going to see this, the precip core separate away from the updraft a bit. You'll see the right edge of that wall cloud and a sharp updraft right here. And then a well-formed and contiguous anvil, not pulsy anymore. And one huge overshoot that's sustaining itself. Now we see in the low levels, start to develop the hook along the rear flank gust front boundary. Classic supercell signatures aloft with BWER and mesocyclone. So it's really coming to town. And then as we go to 2346, 2347, look at the separation between the updraft base and the precip. It's really got more separated. We start to see that the wall cloud really firm up again. Even has somewhat of an inflow tail, but when I start bouncing back and forth in this, I don't see any streamwise inflow current. You see that tail? It just kind of falls apart in place with no cloud elements pushing in or getting sucked into the updraft from the right. So storm doesn't quite have a streamwise vorticity current the way I would normally expect it. But now you can see very kind of linear BWER, kind of a straight hook, so we're not looking at a strong low level meso, but we do have circulation right here. All right, and then over time, as we go on to 2350, 2354, you can see that the storm still has a very, very consolidated updraft, very sharp, contiguous, well-defined wall cloud. And you can see the updraft is probably represented by the leading edge of this hook. You notice the hook is anticyclonically curved, not much of a low-level meso. Instead, really just kind of an outflow boundary, the rear flank gust front pushing out in a horseshoe shape. But the mid-level mesocyclone is extremely strong at this point. At this point here, again, there's a little more lightning density in the GLM. We lost the overshoot a little bit here, but it's mostly temporary. It'll come back, but that's the last part of this segment here. You might wonder about, well, how can we see through this reflectivity core that's just starting to fall? And you might see right here, you can see the clear sky behind it. Why can't we see the precip? Well, there's a possibility here that I might be able to show you, and I'm going to go over to the other reflectivity display, courtesy of Radar Scope. And roughly, I think we're about the same time here. This is 2330, and I'm roughly 2330, about the same time here. Now, I am located roughly about here, and actually a little bit farther southeast, maybe about here. But anyway, we're looking up to the northwest, and we're looking at southwest of Leonville. This part of the updraft base, just a little bit west of Leonville right here, where that new precip core fell. The one thing that could be possible or the one thing that kind of explains why we're able to see right through this core is that the KDP looks really low. This represents the amount of liquid water in the path of the radar beam as the beam extends out and then reflects energy back in. And I think in this case here, because this is showing very little phase separation between the horizontal vertical channels, that there isn't that much liquid water there. So we may be seeing large drops. And in fact, look at the KD or the ZDR, and you can see it's very high. The values are roughly about, let me go to my cursor readout, 4 or 5 dB. This indicates that we have large drops falling at this point. So that doesn't really occult the visible light very easily, whereas it really pops on the radar. You get big echoes that way. So that's why we can see through it and yet still have some fairly high reflectivities. Okay, you may have another question here about, did Prop Severe, this is a product that forecasts the probability of severe weather occurrence given the present state of a thunderstorm, and it was developed by the University of Wisconsin. Did it actually sample these two storms or these two cells as separate, or did it actually combine the two? So let's take a look. Okay, remember that this cell here is a separate updraft and that it grew up dramatically on the left flank or the right flank of the original cell. You can see that new anvil surge here as a visible manifestation. So let's go to Prob Severe and take a look. And here it is. So 2324 is when we're looking at it. Here's the onset of the new core as viewed by the MRMS merged reflectivity. So let's take a look and we'll advance forward. Okay, you notice the Weather Service issued a severe thunderstorm warning right here. And as we go forth here, you can see the onset of the new core developing here. This is already 2328, well after the anvil has expanded out. And you can see roughly there that new surge going up and a rapid development of this new core. So still not quite detecting it at this time. And as we go forth here, now you can see what happens. Prob Severe wound up just assimilating both storms into the same idea as the original cell to the northeast. And so, in other words, the new cell developed too quickly and too closely to the original one to be deemed separate according to the Prob Severe model. Why is that? Well, it's because when this cell developed, it shared the reflectivity core with the original one. It never really was separated enough to be determined as a new one. So that's something to think about when you're looking at individual radar, identifying individual updraft surges with new cells versus a completely different storm that's somewhere else that's not sharing the reflectivity core region in some way. Hey again, this is now a scene that's later. I think it's about 40 minutes later. In fact, we went from 2358 to 0040, and this is now a new position. I moved south of Manhattan, Kansas, and then down Route 177, several miles south of I-70. Here, I turned off to the west a little bit and looked to the northwest, and this is what I see, which is a classic supercell with a couple bands here, main updraft here to the west of the precipitation core. And then to the south, we see evidence of precip falling down on the northwest flank of the updraft here. That's the hook echo, which we see right here. And you notice as I'm looking through this that I have a lot of reflectivity, which appears to be between me and the updraft. But in this case here, a lot of this is fairly light and mainly large drops. So you see a little bit of restriction of visibility on the right side of the updraft, but not too much. We can see pretty much everything we need to. So at this later time, the anvil is huge. It's a monster anvil that extends well out and away from the overshooting top and the storm summit, and the summit is extremely high. The interesting thing is, and I'm not exactly sure why this is the case, but I suspect that the lack of lightning visible on the geostationary lightning mapper is due to the density of the overcast in the anvil and the extremely thick updraft water content and ice content here obscuring the light from the lightning flashes. Now that's an idea. I'm not too confident in that because I'm not exactly sure of the quality of the data coming into the RAM B slider site at this time. So anyway, With that kind of disclaimer there, let's just assume that we're not seeing a lot of the lightning because the optical energy is being absorbed by the dense ice crystal cloud in the storm summit region. So a lot of what we're going to take a look at is just from the sandwich product and also from the radar data here at Topeka, which really is actually quite close. I mean, literally the lowest elevation beam is less than 1,000 feet above the ground. So let's move forward here. The idea here is we're going to look at the onset of low-level mesocyclogenesis. We already have one circulation here way back. It's tucked back behind. We can't see it really from where I'm standing here with this scene here looking northwest. So we are going to look at future mesocyclogenesis, and the idea is we're going to take a look at a precipitation dump that will occur, and some people might call this, well, it's that kind of precip dump that occurs that falls into the hook and then can help spin up a low-level mesocyclone as it brings and tilts vortex lines down to the surface along the periphery of the downdraft. So move forward, and I'll show you where that precip dump is, and I'm stepping forward in time right here. And in fact, I got a signpost and an arrow. So at this point, watch the precip dump right there. You see that? Okay, so that's around 052 or something, 047 actually. And you see that precip dump right there. It falls in. If you look on the reflectivity, the hook echo turns more ball-like at this point. You can see his horseshoe, and all of a sudden separates and it turns into a ball there. But it occurs pretty quickly. And the other thing you notice here is that we have an elongated shear zone along the north flank of the RFD gust front. And along that zone, right after the precip dump, or almost coincident with it, we see the next scan shows a tightening of the low-level mesocyclone. So indeed, there is something going on. And in fact, I could go ahead and just loop this, and you can see later on, you see cloud elements whipping around really quickly right in this region, just for a bit, and it stops right there. And so you can probably see that there was a short-lived low-level mesocyclogenesis. You see that with the precip and then the whipping around, and then the whole thing kind of just falls apart, and you see it falls apart on the radar. So isn't that cool? You can actually see on the radar and what it looks like in person. By the way, that kind of mesocyclone you see, it's really just kind of like tenuous cloud elements whipping around into bands, and you don't see very much in terms of a solid updraft core above it. So that's not a good sign for something to spin up. I would like to see much more dense updraft core. And I'm going to show that to you next. Okay, we're back now. And now take a look at this. Here's the storm. Just a few minutes after the last video, I just moved a little bit to the east, a few hundred yards, and I'm looking northwest, and I see a lowering here, and I see scud. And I'm going to go ahead and move this forward here in real time. Okay, this is not a time lapse, and you can see there's some rotation going and some lowering, but you notice it's ragged cloud elements. I think a lot of this air is occupied by downdraft. I don't see a solid confined, let's say a uniform updraft base. And so with this kind of tattered look to this rotation, it looks like much of this is dry air. Too much dry air got into this. And I looked to the southeast, and now look at this. This is amazing. This is the new mesocyclone. This is real rotation. And you can see it's underneath and embedded directly inside a huge updraft base. So this is going somewhere as opposed to the other one, which didn't have much of a future. Let's take a look at the sound and listen to this. Okay, you're going to listen to the sound increase in time. It's going to start rushing through the wires from the northwest, feeding into that next mesocyclone just to my southeast.
Better watch out in front of us, huh?
All right. So what does this look like on radar? Let's go to the radar here. Okay, so earlier, this is where I'm looking, and I'm right in between these two there's two areas. So here's the northwestern area right here. If I advance forward, you can see it spins up. So I got about 10 meters per second inbound, 10, maybe 16 outbound, 18 outbound. So I'm looking at about 13, 14, 30 knots of rotational velocity. Not a bad mesocyclone. If you didn't know that this mesocyclone had so much dry air in it, you'd be tempted to say, hey, this is worth a tornado warning. I agree. Hey, overall, this is a strong supercell. The environment's pretty good. I think it warrants this tornado warning. But this one has problems. Later on, just to my southeast, look at this thing spin up. 12 inbound, 10 outbound. So 11 meters per second, 23 knots. Next time frame, boom. Now we got 16 to 20 meters per second inbound, 14 outbound. We're talking about 15, 17, 18 meters per second rotational velocity. That's 36 knots. It's getting up there. That's pretty good. And it keeps intensifying. And you can see enhanced inflow coming into it from the radar straight into the circulations. That's real rotation. You can see it intensifying. And of course, you know what happens next.
Now we have a tornado.
Okay, so it doesn't last long and my video starts creeping upward, but I think you got the idea. That one did produce not a strong tornado, didn't last very long, about a minute long, EF0, it was over a field, didn't hit anything. And then it kind of lost vorticity, but that was the one that was strong enough. In fact, there's a little bit of action down here visible underneath, lowering once the funnel lifted, but eventually it ran out of vorticity and weakened below tornado strength. But anyway, that was the show, and hope you enjoyed it. Talk later.